Resistance. For use with AS physics, R is equal to V over I. That means the resistance of a component is equal to the voltage across it divided by the current through it. And here we have that actually written again. Defined the potential difference across a component divided by the current through the component, or V over I. So that is resistance. Example 1. If we take a single resistor and we have it in a circuit with a single cell producing 1.5 volts, we can work out its resistance as long as we know the current through that component. And to do that, we need to use a voltmeter and an ammeter, and they will both give us some given values that we can use in that original equation that we saw, which was R is equal to V over I. So there we have our ammeter and our voltmeter, and let us presume that our voltmeter has said that we have 1.5 volts across the resistor and a current of 30 milliamps. If we substitute both of those values into the resistance is equal to voltage over current equation, we end up with 1.5 divided by 30 times 10 to the minus 3. This gives us 50 ohms, and we're going to use this resistor in the next two examples. Example 2. Resistors in series. Now, for this resistor, we are going to imagine that we have 15 milliamps flowing through it, but we have 1.5 volts across both. We now want to know the total resistance of the two resistors combined. We're going to presume that we have used the same resistor as before, so we have two resistors, both with 50 ohms. If we now substitute those values in, we end up with 1.5 divided by 15 times 10 to the minus 3, and that gives us 100 ohms. And this is the total resistance. Therefore, for resistors in series, we simply add the resistance of both of our resistors together. In example 3, we are going to see two resistors that are in parallel. If we take the current flowing out of the battery, out of the cell, to equal 60 milliamps, and the voltage across the component is still 1.5 volts, we see that for this instance the resistance, which is equal to V over I, 1.5 volts, divided by 60 times 10 to the minus 3, gives us a total resistance of 25 ohms. This is less than the individual resistors' resistance. This is because more current can flow around the circuit because any individual branch of the circuit, represented by the following arrows, would be the same as our original example, with 30 milliamps flowing through the component. However, as we have two of these components, we add together the total current flowing through both of them, and in this case that gives us 30 milliamps, leading to a resistance that is lower than the individual component's resistance. So, to recap, resistance is the potential difference, or voltage, divided by current. The units of all of the different aspects we have seen today are ohms for resistance, volts for voltage, and amps for current. And the symbols are there for you to have a look through when you go through this video again.